Question 1. In your words, what is the immune system?
The immune system is one of the systems in the body, just like the cardiovascular system or the respiratory system or the musculoskeletal system. It's actually the largest system in the body by tissue mass. Most of it is fluid. Some of the main components of the immune system include white blood cells that circulate in our bloodstream and help to fight infections and inflammation, and also the lymph glands that we have in our neck and in other parts of our body as well. Basically, the immune system fights off infections, germs that we breathe in every day, germs that we eat, and identifies these germs and then tries to eliminate them.
All right, thank you. Question number 2. What happens to the immune system when it's in outer space, and what are the consequences?
Well, we do know from the earlier space flights that some astronauts and cosmonauts have suffered from immune-related disorders in space. So besides these anecdotal stories from astronauts and cosmonauts, the only hard data that we have of immune function in space is taken from blood samples, saliva samples, urine samples immediately before space flight or immediately after. My crewmates and I had the opportunity to fly aboard the space station for 6 months. So before flight as well as after flight, and several occasions during flight, we took blood and saliva samples from each other and sent them down to the Earth to be analyzed. And the experiment confirmed that there is immune system dysfunction that occurs in space.
Question number 3. What is the biggest cause to the immune dysfunction in outer space?
Well, that's the million-dollar question. What causes immune dysfunction in space? Some people speculate that it's the weightlessness aspect of spaceflight. We don't have any hard evidence about that from spaceflight experiments. We do have some experiments that have been performed in a laboratory setting on Earth that show that weightlessness has effects on at the level of a cell or a level of a tissue. Some of the microcellular structures that are part of a cell structure, microtubules, for example, don't get built properly in an immune cell. Some T cells don't seem in a laboratory setting to work as well in a simulated microgravity environment. But we don't have proof for that yet in space. There's other factors associated with spaceflight that also might be contributing as well. Ionizing radiation, for example, could be a factor. The physical and the psychological stress that astronauts are subjected to during spaceflight might be a factor. And also the sleep disturbances or circadian dysrhythms that occur during spaceflight as well could all be part of the stresses to astronauts and cosmonauts that could cause the immune system to dysfunction.
And then so this is more of kind of your opinion, but once we fully find the reason and how to kind of figure out how to settle down the immune system and get it on a pretty even working base, what would you see the future in space study?
What we have to do is to protect future astronauts who will be going on interplanetary space flights. So we do know that the immune system doesn't function as well during spaceflight as it does on the ground. So the T cells and the monocytes don't function quite the same as they do on the ground. There's reactivation of what we call latent viruses as well during spaceflight. So that, plus longer duration space flights, plus the effect of ionizing radiation that's unknown on the immune system could cause problems for future interplanetary astronauts. So we're going to need to use the findings from scientific experiments that are done today in order to think about countermeasures or ways to prevent or treat immune dysfunction in the future. So infections on astronaut crews, on future space flights, rashes that might occur, and then also inability of the body to fight off newly developing cancer cells as efficiently as the immune system could otherwise do on Earth.
Right. Thanks. You boys have any questions you'd like to ask? I think that's it.
Yeah.
Great. All right. Thanks a ton, Bob.
Okay.